who here has written a Rails app before? Just checking. Cool. So most of the room here are Ruby programmers, Rails developer, right? So like you've probably written some code similar to this at some point, where you have a controller and you have like a index method or a show method or whatever. And inside the method is just Ruby, right? Like we know how Ruby works, we know like maybe you put post.find there, but like we can understand all that. Post is a class, find is a class method, so post.find calls that method. Well, it's just all Ruby through and through. But have you ever wondered how did we get here in the first place? Like when you type scala.io/hello in the browser, how did it make all the way to your index method? Who calls that? And how does a web request get turned into something inside Ruby? That's what this talk is going to be about. And to tell you more about that, we have Sek.
So let's say you are meeting somebody for lunch. Meet at Pastini probably works for your coworkers who go there a lot, but it probably doesn't work for your out-of-town friend who's not familiar with the area. Instead, you can give them the street address. That way they can give it to their cab driver or just ask anyone for directions. Computers work much the same way. Skylight.io is easier for us to remember, but it doesn't help your computer find the server. When you type skylight.io in your browser, the first order of business is to connect to the server. And to figure out how to get there, they need to translate that name into an address. For computer networks, this is the IP address. It looks like this. You've probably come across it at some point. With this kind of address, computers can navigate the interconnected networks of the internet and find their way to their destinations. DNS, which stands for Domain Name System, is what helps our computers translate the domain name into the IP address that they use to find the correct server. You can try it out for yourself with a command line tool called dig on your computer. The output looks a little bit intimidating, but the main thing to look at here is that it translated skylight.io into 34, 194, 84, 73. The DNS is a registry of domain names mapped to IP addresses. When you buy or own a domain, you are in charge of setting up and maintaining this mapping. Otherwise, your customers can't find you. Okay. Once we have the IP address of the server, our browser can connect to it. The way the browser connects to the server is actually pretty interesting. You can think of opening a connection between the two, like picking up a phone and dialing someone's number. In fact, why don't we try it? There's another program on your computer called Telnet that lets you open a raw connection to any server. Here we are connecting to the server we found earlier on port 80, which is the default HTTP port. Once we have connected, we have to say something, but what do we say? Hi. Unfortunately, that doesn't get you very far. What do you do when you pick up the phone and it sounds like a spam call? You hang up. So let's try this again, but this time doing it properly. The browsers and the servers have to agree on a language for speaking to each other so that they can understand what one another is asking for. This is where HTTP comes in. It stands for Hypertext Transfer Protocol, which is the language that both browsers and web servers can understand. To make the request for skylight.io/hello, here is the simplest request that we could make. It specifies that it is a GET request for the path /hello using the HTTP protocol version 1.1 and is for the host skylight.io. A simple response from the server looks like this. It specified that the request was successful, gives a bunch of header information, and finally, hello world, the text we rendered from the controller. HTTP is a plain text protocol, as opposed to a binary protocol, which makes it easy for humans to learn, understand, and debug. Provides a structured way for the browser to ask for web pages and assets, submit forms, handle caching, compression, and other mundane details. And by the way, here's a side note. Just like your phone line, the connection between the browser and the server is unencrypted. The request goes through a lot of places to get to the other side: the conference Wi-Fi, the convention center's routers, our internet provider, the server's hosting company, and many other intermediate networks in between that help forward the request along to the right place. This means a lot of parties along the way have the opportunity to eavesdrop in on the conversation, but maybe you don't want others to know what conversation you're having. No problem, you can just encrypt the contents of the conversation. It will still pass through all of the same parties, and they will still be able to see that you're sending each other messages, but those messages won't make sense to them because only your browser and the server have the keys to decrypt them. This is known as HTTPS. The S makes it secure. But it's not a different protocol from HTTP. You're still speaking the same plaintext protocol that we saw earlier, but before the browser sends the message out and encrypts it, and before the server interprets the message, it decrypts it. The encryption-decryption is done by using a secret key that both the browser and the server have agreed upon and no one else knows about. But how do the browser and the server pick what keys to use for encryption and decryption without giving them away while all the other parties are listening in? Well, that's a topic for another talk. Okay, so by now your browser has successfully connected to the server and asked it for a specific web page. How did it generate the response? To tell you about that, let's push IDE on the stack.
Thank you, Zach. All right, so that is a good question. How did it generate this response? Well, first of all, we have to figure out what kind of server this is. Well, it's a web server, which really just means that it speaks HTTP, as we saw earlier. So there are quite a few different examples of web servers. Here are a few. We have Apache, Nginx, Passenger, Lightd, Unicorn, Puma, and even WebRick. Some of them are written in Ruby, while others are written in C. And their job is really just to parse, which just means understand, what the request is. And they have to make a decision about how to service that request. For simple requests, like serving static assets, you can easily configure a web server to do that for you. So, for example, let's say that we wanted to tell the web server that whenever a browser requests anything in assets, then the web server should try to find that file in my app's public assets folder. And if it exists, it should serve that with compression. Otherwise, it should return a 404 not found page. Depending on which web server you're using, there are specific configuration syntaxes and languages that you might want to rely upon. For example, if you're using Nginx, you probably would write something that looks like this config file. For more complicated things, however, it gets trickier. For example, we might want to tell our web server, hey, whenever a browser goes to /blog, I want you to go to the database, find the 10 most recent blog posts, and then make them look pretty, and then show some comments, and maybe throw in a header and a footer and some JavaScript and some CSS, and off you go. Easy, right? Well, this is maybe a little too complicated to express in the web server's configuration language. But that's what we have Rails for. So really what we want to do is tell our web server that it needs to hand these types of requests off to Rails for further processing. But how is the web server?
So as we learned so far, frameworks aren't magic. They are just a layer of conventions that live on top of a nice primitive under the hood that works really well. Conventions can help you learn, can help you collaborate with your team, and we all love conventions or we wouldn't be here. But more than that, conventions give the community the ability to write tools that everyone can share. For example, Skylight needs to wrap around our entire request so we know how long it took. Well, if we've been paying attention, we know how to do that. We use a middleware. What better way than a middleware? Convention over configuration is more than how you build Rails apps. It also allows Skylight to give you a lot of detailed information without having to configure anything. So in a lot of ecosystems, tools like Skylight would require you to do a bunch of work to get things running. But because Rails provides such good conventions, we can leverage those in order to make your life easier, to make the getting started story easier for you. Earlier on, we saw how Rails dispatches actions, but we skipped over this part at the bottom. You may or may not know this, but Rails has a built-in instrumentation system, and we can get detailed information about what's going on inside of our requests without hacking into private APIs. For example, this section over here is how we get the name of your endpoints without you having to tell us anything about what they're called. Now, Skylight does way more than just give you the average of the response time for your request. We give you detailed aggregate traces of your entire request. We leverage active support notifications and Rails conventions to provide conventional descriptions for Rails and for common gems without any configuration. By default, we also show you important parts of the request so you can focus on speeding up what matters. So if you look at this example over here, that big, I don't know if you can see the color, but I think it's purple or something. You should probably focus on the app serializer because that's taking up so much of the time if you want to speed up this endpoint. But we still collect way more information that we hide by default. So if you uncheck the condensed trace checkbox at the top, you can see that each middleware that we saw before is here in the expanded trace. And as you can see from this screen, everything is errata. Now there's way too much stuff to tell you about in this talk, like the fact that we do a ton of our work in Rust, and by the way, we have official background job support this year. But come to our booth to hear more about that and chat.
And to communicate with Rails. Well, in Ruby, there are lots of different ways to communicate this kind of information. So Rails could potentially register a block with the server, or the server could call a method on Rails, and the server could pass that request information along as request arguments, environment variables, and maybe even a global variable. And if we did end up going down this path, what kind of object would these look like? And then of course, there's another question to answer on the flip side, which is how Rails would communicate back to the web server. Ultimately, all of these options actually work. And at the end of the day, what's more important is not which option you pick, but rather that everyone is agreeing on the same option. It's important that we all agree to the same conventions. And that is why Rack was born, to present a unified API for web servers to communicate with Ruby web frameworks and vice versa. By implementing the Rack protocol, all web servers, all they have to do really is just implement a single adapter for Ruby. And any one Ruby framework that conforms to this convention will just work seamlessly with these web servers. So Rack is just a simple Ruby protocol, and all that means is it's a convention. And Rack does a few different things. So first, the web server needs to tell the web framework, hey, I have a request for you to handle. And by the way, here are like the deets for the request. You know, the path, the HTTP verb, the headers. And then the framework needs to tell the server, it's cool, I handled it. Oh, and also here's your result. Your status code, your headers, the body. In order to remain lightweight and framework agnostic, Rack picked the simplest possible way to do this in Ruby. It does a few different things, like it notifies the web framework using a method call, and it communicates the details in the form of method arguments. The web framework communicates back by responding with some sort of return value from that method call. In code, it looks a little bit like this. We see that the web server prepares a hash, which conveniently is called the env hash. The env hash contains all the headers and a path. So for example, we'll see that request method contains the HTTP verb, for example, get or post. Path info, as it's named, contains the path request, and HTTP _ star has the corresponding header value. An important thing here is that your app has to implement a call method. And again, we see convention at work here, because the server is going to expect that call method to exist. Why? Because the server invokes the app's call method with the env hash as the argument that's passed in. The app will process the request based on the information in the env hash, and it'll return an array with exactly 3 things in it. Pro tip, another way to refer to this is a tuple of 3. So what are the three things in this tuple of three? First, you have the HTTP status code, which is just a number. Second, you have the header's hash. And finally, you have the body. Now, intuitively, we might think that the body should just be a string, but it's actually not. For some technical reasons, the body is actually just an eachable object, as in it just needs to implement the each method, and it yields strings. In a very simple case though, you can just expect it to be returned as an array with a single string in it. So let's see this in action. To guide us through the Rack API, I'm going to call on Godfrey.
Right, so like the goal of the talk is to understand Rails and then forget that, but before we get into Rails, let's just try to use this Rack API that we learned by itself, right? So let's say we write a simple Rack app. This is probably one of the simplest Rack app that you can write. You can see that it's an object. It has a call method on it. It takes an env hash and it checks what is in the env hash, right? So specifically, it looks at the path of the request. If the path is /hello, then it's gonna render 200 response. That's the status code. 200 stands for a successful request. And as we said, we need to return an array with three things in it. The first thing is 200. The second thing is a hash of headers. In this case, we want to tell the browser this is a plain text, so don't bother trying to interpret it as HTML or anything like that. And finally, the third thing is an array of the body, in which case we're returning plain text hello world. And so else, if the path is anything else other than hello, we're going to do a for. I'm sure you have encountered that in the past. For stands for not found, right? So we're just going to do a very simple plain text response of not found if you go to anywhere other than /hello. Okay, so now that we've written our app, how do we use it? How do we call it? How do we make it do things? Well, as we said earlier, Rack is really just a convention, just a protocol, right? Like you notice that this didn't have to subclass from anything specific. It just has, like, it can just be any object that responds to call. So to hook that up to HTTP request, you need a web server. Again, that's what we talked about earlier. So we can hook this up with Nginx or Apache, but fortunately, for this kind of simple demonstration, Rack came with a pre-built script that's kind of like a web server that natively like a Ruby web server that natively understands Rack protocol called Rackup. To configure the web server, you can use the config.ru file. It's basically a Ruby file with some extra DSL. So you can see that the first thing we're doing in this config.ru file is to require the app file that we have up there. And the only other thing in there is to run hello world.u. So run is the keyword in the DSL that tells Rackup, hey, this is the app, the thing on the right-hand side, in this case hello world.new, which is an object with a call on it, as we said a couple of times by now. So finally, to really put all these together to run it, you can just run the command Rackup from the same directory where config.ru is. You can see under the hood, Rackup just wraps whatever Ruby web server you have. Sometimes it uses thin, sometimes it uses WebRick, but that's implementation details, right? Like as far as we're concerned, Rackup is a web server that understands config.ru, which understands Rack apps. So now, if we open the browser, go to localhost 9092, so 9292 /hello, we're going to get the hello world response. And if we go to anything else like Somagon or /web, we're going to get our not found. Great, we have written Rackup. So now let's make it do a little bit more, right? Like let's say we want it so that when you go to localhost 9092 / right now you get not found because / is not /hello. So why don't we make / redirect to /hello? So to do that, you'll probably modify your Rack app to be something like that, right? The part to focus on is if we first check if path info is /, we return a 301 response code, which is a response code for a permanent redirect. And in the headers, we return the location of the redirect, which is /hello. So this works great. If you open the browser now with a slash, it will redirect you to /hello. Everything is awesome. However, as you can imagine, if you keep adding things to here, this if statement is going to get pretty big, right? Like, as you have more pages, this is like you're going to have like a 100-line if statement. And also, redirect is a pretty common thing that you might want to use in different parts of your app. So it would be great if we can extract this into a reusable, composable piece of code. And we can do that. So magic, there's more code on the screen now. On the bottom, it's exactly the same Hello World app that we had on the previous screen without any concerns about the redirect, right? Like we can see that Hello World is back to the state that it was. It doesn't need to know anything about redirects. And we made a new class on top called redirect that is only responsible for handling the redirect aspect of the app. So you can see that in the call method, we first check if the path matches what we want to redirect from, then we'll intercept the request and return like right away and just tell the browser to redirect. That will be it. However, if it doesn't match where we want to redirect from, then we're just going to delegate to the app that's passed in to us to do more processing. And to wire everything up, it's going to look something like this, right? Like this time instead of passing hello world.new to run, we're going to pass redirect.new, but passing hello world.new to that redirect app that we made earlier. So this is great, and it works. And in fact, we just made our first rec middleware. You might have heard of that word before. This is exactly what it is. Rec middleware is not necessarily unlike the rec app call protocol. The middleware is not like a concrete concept in the rec spec. It's just a very useful convention. Like basically, as far as the web server is concerned, there's no middleware, right? Like there's just one app with a .call on it. What you choose to do inside your .call is up to you. And in the case of a middleware, it just happened to choose to sometimes forward it to a different app, right? That's really it. But because of how useful this middleware convention is, the rackup config.ruDSL has a special syntax for that. So basically, the only problem with this here is that the nesting gets a little bit uncanny, and you can imagine if we want a lot of middleware, that right-hand side is going to look like a very deeply nested thing. And so the rackup DSL has a way for you to flatten it. Basically, instead of run, you can use the use keyword to specify a list of middleware before you specify the app. So this is pretty powerful. The rec gem itself ships with a bunch of very useful middleware that you can add to your app. So for example, something like this. Basically, without writing without running any code really, you have added compression to your app. You have added HTTP caching to your app, and you have handled head responses. So that's the power of the middleware convention. Right? So to recap, this is like the whole RAG concept. Basically, we've learned it all, and so it's now time to go back to Rails. So the whole point of this detour into RAG is to say that web servers uses direct protocol to communicate with Ruby web frameworks. So therefore, it must mean that Rails implements direct protocol, right? Otherwise, what's the point of this detour? And it does indeed. If you look at your Rails app, you'll see that Rails actually generated a config.ru file for you. You can check it out in your work app later. But it probably looks something like this, right? Like it has one single, well, other than the require, it has one single line called run Rails.application. So we know that the convention for the way that the rackup DSL works is the thing you pass to run is a rack app. So therefore, it must mean whatever Rails.application is, it must be a rack app, right? So let's try that. So you can try that by running the Rails console, and we can just do rails.application.call, right? But the problem is, in order to call a rack app, we have to pass it the end hash. Obviously, we can just build the end hash by hand, but this is a lot of work and pretty error prone, right? Like you have to really carefully read the rack spec to make sure you're passing all the things as expected to be there. But fortunately, rack has a utility for exactly this purpose. It's called rack mock request.end4, and you can just pass it a URL and it will build the corresponding end hash for you, which is very useful for testing and stuff. So now that we have the end hash, we can try calling rails.application.call again. So if we do that, you'll see that it kind of does what you expected. Like it might be a little bit surprising, but it actually worked, right? Like when you did Rails application to call, it actually ran the entire Rails app, including giving you the logging output that you're probably familiar with. And in return, as we mentioned earlier, return an array of 3 things. If you're not familiar with that syntax, that's how you can conveniently destructure the array from the return value and assign names to them. So if you look at what the status is, well, it's 200. If you look at the headers, it's among the things that's content type in there, and a bunch of other headers that Rails added for you. And if you look at the bodies, again, body is an array, so it takes a little bit more work to look at it. But if you print it out, you will see that it's the HTML response that you expected. So that's pretty cool. We found the Rails app, like the Rails rack app integration point. But if you look at config.ru, you remember that earlier we said there's 2 things you can put in a config.ru. You can put run and give it an app, but you can also specify your middlewares there, right? Like that's what the use keyword is for. And you can see that there's no use keyword, so this Rails not use any middlewares. Well, it turns out Rails just handle middlewares differently, but if you want to look at the Rails middlewares, you can run bin Rails middleware, and it will give you all the middleware in the syntax that you're familiar with. You can see that Rails implemented some of its internal features in middlewares. This is pretty cool because if you don't need some of these features, you can just take it out. So for example, if you are writing an API server, you might not be using cookies, right? So does this mean that you're stuck